Okay, so let's do the practice problems for Module 2, Lesson 5. Forgive my scratchy voice, I have a cold. um, okay, so in 8.9, we're going to use truth tables to determine the validity of this argument. And I have done this ahead of time, so I won't make the same mistakes as I did in the video where I was trying to do it on the spot. So we're going to start by looking at the argument and counting the number of propositions or variables. We have P and Q, so just two. So we're going to need start with two columns. Let's put this down and do the first one on our own. I'm gonna click insert table, and we're gonna start with two columns, and then we'll add to it. And the number of rows are gonna be 2 to the number of variables, so 2 to the second power. So that's 4. And then actually I need 5 because I'm gonna insert one row below because we need this to say P, Q at the top. And then we're gonna start doing these sentences, starting on the inside of the parentheses. So first we're gonna insert a new column, insert column to the right, and we're gonna need one for P or Q. And, oh, sorry, I haven't done the true. So the convention is to start with the rightmost variable and just alternate true, false, and then go one in and you go true, true, false, false. And that's going to give you all of the options. Either P and Q are both true, or they're both false, or one is true and the other is false in both ways. All right, so anytime either of these is true, the P or Q will be true. So looks like that. Next, we're going to need to do P and Q. Remember, and can be a dot or the upward wedge. I like the upward wedge because it's easier to type out. P and Q. That's going to be true anytime P and Q is true, which is actually only in that top row. Columns to the right. Now we need the conditional overall. So this is the antecedent and this column is the consequent. If the antecedent is true and the consequent is true, the overall conditional is true. Here the antecedent is true and the consequent is false. That makes it false. Same thing. Here the antecedent is false, and whenever the antecedent is false, the overall conditional is just true no matter what. All right, so this, we finally have premise 1. Let's highlight it. We'll do yellow. And now we want to look at, premise 2. We actually already did premise 2, so we don't need to do it again. We'll just highlight it. And now we're going to look and find, those are all the premises, so we're done making our truth table. We might not be done. We have to also do the conclusion. But look, the conclusion happens to already be done as well. Let's highlight that in a different color. So what we're looking at to see if the argument is valid, this is how we use truth tables, is to find any of the rows where all the premises are true. There is only one row, this top row, where that's the case. So we only care about the conclusion in that case. It looks like it is also true, and that means this argument form is valid. All right, so we're going to do the same thing. I'm not going to take you through. This is just me working it out earlier. Can delete that. Sorry, also working it out earlier. Okay, so let's go to the next question. We're going to do the exact same thing. Sorry, I just tried to make a video and then I messed up the video. That's why I have more examples. Here, notice I'm not going to do the whole thing because the video is already getting really long. But look, we also have R here, P, Q, and R. So we're going to need more rows. So let's start with a column for P, Q, and R. And how many rows do we need? Well, we need 2 to the third power because there's 3 variables, which is 8. 2 times 2 is 4 times 2 is 8. And then again, you're going to start with the innermost one and you're going to go down true, false, true, false, true, false, true, false. And then you're going to go by twos. True, 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 false, false, true, true, false, false. Then you're going to go by fours. True, 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 false, 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 false. And if you had more, you'd go by eights next. Then you'd go by 16ths. I'm not going to ask you what that many. They start to get unwieldy, and then but anyway, that's beyond the scope of this class. And then we're just going to go through and make a column for each of these sentences in the premises. And so I've already done this. We'd have to figure out Q or R and then do the column for not Q or R. So what we want to look for, let me just unhighlight this. So we want to look at our premise columns here and find any where both are true, where all the premises are true. And it's only in this last row. So we want to look at this last row and then look at the conclusion and see if it's also true or not. Since the conclusion is indeed true in this last row, the argument is valid. Same thing in this next exercise set, except we're going to construct it with variables. So the question gives us this: you can either face your problem or run away from it. Make face your problem P, run away from your problem Q. If you're brave, you'll face it. We'll make R, you're brave. So we have either P or Q as the first sentence. The second one is if R, then P, the second premise. So if you're brave, you won't run away from it. So if R, then you won't run away from it, so not Q. And then we're going to do the same thing. We have 3 variables, so we're going to start with 3 rows, P, Q, and R. And we need, 3 columns, and we're going to need the number of rows of 2 to the third power, which is 8. We've already done. We're going to alternate true, false, true, false, true, false. This will go by 2s, true, true, false, false. This will go by 4s, and we'll have all the, we're starting here. And then we want to do P or Q. P or Q will be true whenever the P or the Q is true or both are true. I've already done that. Then we want to do this. If R, then P. That will be true, or maybe for a conditional, if the premise is false, the conditional is already true, is automatically true. And then if the premise is true and the consequent true as well, that will also be true. So basically it's only false in cases where R is true but P is false. So you can see it's only false in cases where R is true and P is false. And then in order to do, we need to do the conclusion. Well, first we need to do not Q, because remember we have to start with the not. So we did this not Q column real quick to figure out the if R then not Q. And then we are going to look at, highlight the 2 premises. I've already done that here. And then look at the column with the conclusion. I'll highlight that as well. And we're going to look for any of the rows where both are true. Look, these are both true. Oh wait, but look, this is false. Oop, that means we've got something invalid going on here. And the rest, it looks like, are true, but it doesn't matter. We have one case where we have true. The rest, these are also true. The conclusion is true, but it doesn't matter. We have one case where the premises are true and the conclusion is false. That means it is an invalid argument. This one also, we can see how affirming the consequent is invalid. We have our premises of if P then Q and Q are true in both of these cases but false. In this row we have the premises are true and the conclusion is false. That makes it invalid. write the corresponding conditional. So this is just teaching you how to use parentheses, basically. You're going to want to take this, put some parentheses over it, and you're going to use and to string them together, and then parentheses on the outside, and then Q. You can kind of look at the answers in the back of the book, but it's just trying to teach you that for each small, for each premise, you're going to want to put parentheses around it to keep it organized. And then, right, this next premise, I put parentheses around, and next premise, I put parentheses around, and then parentheses around the whole thing. And then I made the conditional the main connective. That's all it's asking you to practice here. Lastly, running out of time, but we're going to make it. Use the sentences. So it just shows you, this is the question. Use the sentence letters to represent simple sentences in English. Translate each into the appropriate sentence form. And then use a truth table to decide whether the sentence is a tautology, a self-contradiction, or a contingent sentence. You cannot win unless you try. Unless is says it might be a conditional. So you're going to want to review those indicator words for conditionals or conjunctions. So you cannot win unless you try. So unless also says there's probably a not. So unless you try, if you do not try, so if not Q, that's what I'm getting from that, then you cannot win, then not P. So that's how I translated it. Your book might have done it differently. There are often multiple ways to translate an English sentence, and sometimes, right, and the truth tables will be, you're going to end up with the same truth for sentences that are logically equivalent, right? If they're both okay for you to translate that way, they're going to have the same truth table, truth values. So we're just going to do the truth table for that. Again, we have P and Q. We have to translate not P and not Q to get this final value. And when something is contingent, it just means there's truths and falses in this final. There's 4 truth possibilities for if not Q, then not P. And it ends up being 3 truths and 1 false. That makes it contingent because there's a mix of truths and falses. The same with this one. I translated it as not P and Q. There are multiple ways to translate it correctly. I translated but as and not, basically. You can see there's a mix of truths and falses. That would make it contingent. I'm going to skip ahead and show you a tautology are cases where the final truth values of the sentence are all true. That makes it a tautology. Again, the final on J, the final truth values are all true. That means that sentence is a tautology. It's true like in virtue of its structure. We didn't have an example here, but if you were to get a sentence where all the possible truth tables were false, we would say that that sentence is self-contradictory. It's a self-contradiction, meaning it could never be true just in basis of its structure. All right, I'm out of time. Sorry for the long video. I hope this helps as you're studying for your final exam.